Assalamu alaikum. In this video on optical fiber introduction, we will learn about the physical characteristics of optical fiber cable. So this is basically the second part of my 3 video series. The first part was about the light and glass because basically optical fiber is a glass fiber. It's a very thin strand of glass and the light passes through it. So if you want to know the very introduction of optical fiber, then you should see my first video as well. And this is the second video. In the third video, I will talk about the technologies that work on optical fiber networks. So let's go and see. This is a normal fiber which is brought to your home if you are using a fiber to the home connection. Generally you cannot know very easily that if this cable is a power cable or a optical cable. There are some indications, something written on the cable, you can know from that. Also, if this cable is open in front of you, then you can see that there are tubes inside this cable and each tube is carrying 2 optical fiber strands. So this thread of glass, this is basically the optical fiber that is coming out of this cable. This cable has 12 fibers. These are 6 tubes and each tube has 2 fibers. So generally you can find this cable in with 12 fibers or 144 fibers. 144 is a bit more thick, but not too much. I mean, it's a bit more thicker than this one. And in the center you can see there is one material. This material is to give strength to this cable, because otherwise, as you can understand, these are glass fibers. So if you don't reinforce this cable through something in the middle, then these fibers may be broken if there is any pressure, or if you pull this cable, then you can break the fiber very easily. Generally, if you want a very reinforced cable, then there may be steel wire inside, because some cables are hang up on the towers just like electricity cables. So they have a steel wire in the center, and this steel wires give the strength to these optical fibers. So let's go inside and see deeper in the fiber. So this is basically the geometry of the fiber that we were looking right now. This the fiber that was the fiber that was coming out of that cable. This fiber has typically 3 parts or 3 sections. The part in the center is called the core. The core, all the light which is traveling from this optical fiber, this light is passing through the core of the cable. This coating on the core is called the cladding. This core and this cladding, both of them are made of glass, but the refractive index of core is higher than the refractive index of the glass. This is to ensure that all the light which is going through the core, it remains inside the core, because it will not go outside the core. I will show you that how this is done. And this cladding is to give a kind of protection, because this is a glass strand. So this cladding protects, this coating protects this glass from breaking. It does not break very easily. So if we talk about light propagation, now here we are only looking at the core and the cladding, because our light travels through these only. The light basically travels through core, but a very small part of it can go in the cladding as well. So what happens is, for example, if you put some light source here and some rays are able to go inside this core. So because this core has a refractive index and this cladding has a lower refractive index, So as you know from the physics principle that when a light it is traveling in the media, homogeneous media of a same refractive index, then it goes straight. And once the media is changed, I mean from one refractive index go to another refractive index, then the light bends. So basically if this is a lower index, then the light will be bent outwards, like we can see right now. The light is bending inside the core. If it has a higher index, then light should be bending outwards, so all light should go away. So we made it in such a way that the refractive index of the core is lower than the refractive index of the cladding. So all the light which comes from the source, it remains inside the core. And on the edge of this core and cladding, there is a total internal reflection. All the light which is incident on this point, all this light is reflected back. So uh, the light ray, it kind of ping pongs inside the core, and it remains inside the core. And because the total internal reflections are lossless, so there is generally almost no loss when the light is traveling inside the core. And if we have a source here which is allowed to provide more than one rays, there are more than one rays inside the core, then each ray is called a mode. So based on the modes, we have two kinds of fibers. One is called a multi-mode fiber and one is called a single mode fiber. In the multi-mode fiber, again we have two kinds of fibers based on their diameters and the kind of refractory index that we have. If we have a step index and the fiber is 50 micrometer, the score size is 50 micrometer. 50 micrometers, you can assume that it's very thin. It's thinner than the normal hair of the human. So in step index, what happens is that the refractive index of the core is same and it changes in a direct step. I mean, the core has one refractive index and the cladding has another refractive index. So in this case, when the light ray it reaches the junction of core and cladding, then it is reflected inside. But in case of graded index, the core also don't have a simple or a single index. The index of the core is reducing from the center towards the cladding. So center has some different index and this part has a different index, and as you go towards the cladding, the index is gradually decreasing. That's why it's called graded index. And because it's gradually decreasing, so light turns inside in a gradual way, not in a very sharp way. But because this has a very large area from where it can take light, and because light is very, you can say the wavelength of light is very small, so we can have multiple rays traveling inside this core. And because there may be multiple rays, that's why it's called multi-mode. And this multiple rays, even though from the face it may look better to some people, but generally it's bad for us. So multi-mode cable, we cannot transmit a lot of data to a very long range. So we can, for example, the bandwidth data distance product of this fiber is only 500 megahertz kilometer. So if you want to travel on the speed of 500 megahertz, you can just go 1 kilometer, not beyond that. So that's why it's used in buildings and very short links. Because if you want to put a very high capacity links like 10 megahertz, if you want to use 10 gigahertz of spectrum, then you are limited with the distance. The distance may be very small, only a few hundred or less than 100 meter. But in contrast, this single mode fiber, this fiber has a very thin core. The core is only 9 micrometer. If you do a comparison, it's, you can say, almost 7 times more thinner than the multi-mode fiber. So because of its so much thin, it cannot take more than one ray at a time. If a source is here, the source can only send one ray of light inside. So that's why it's called a single mode. And the good thing of single mode is that the bandwidth distance product is very high. You can go up to 100 terahertz for 1 kilometer. So if you reduce this terahertz, if you come in the vicinity of gigahertz, then you can go thousands of kilometers. So generally we send the light in gigahertz, like 10 gigahertz or 50 gigahertz or 100 gigahertz spacing. So even for 100 gigahertz, you can go very easily 1000 kilometers without any problem. So this is used in long haul links, and you can make a link of thousands of kilometers with the help of single mode fiber. For transmitting on this single mode fiber or multi-mode fiber, generally we use laser diodes. Initially LEDs were used, but the problem with LED is that their spectrum is very broad. They cannot send in a very on a single frequency. You have a central frequency, but the side channels are also very strong. So that's why you cannot use it for any real purpose. So we use laser diodes. Laser diode, as you can see, the central channel is very strong, and the side channels, they are very weak in comparison to the central channel, so they can be very easily segregated. So this is the one which is used in the telecom network because it has very tighter wavelength control. And on the receive side, we use photodiodes to uh, detect the light and convert it to electrical signals. So for example, if you have to make a link on fiber, then you have to take care of the optical budget. Optical budget is basically output power on the one side and the receiver sensitivity on the other side. For example, if I can send power with minus 10 dBm and I can receive power on minus 33 dBm, so it means that I have a budget of 23 dB on this link. But this budget is not only related to the distance, to the attenuation of fiber. We also have, because this fiber is generally not a single fiber, it is made up from many different fiber reels, because you cannot make a reel of 40 kilometer or 100 kilometer long. The reels are like 4 kilometer, 8 kilometers long, so you have to splice these fibers together at some points. Like for example, this fiber may be made by using 8 kilometer fiber, then it may be spliced at 5 points. So there is some splicing loss. Also, when you go inside the building, you use some patch panels or some connectors. So there is some connector loss as well. And the components which are used in on the both of the sides, this component can also use some power. Also, when you are using a fiber in the ground or on towers or in any way, there may be some bands, some very micro bands in the fiber. Those micro bands can bring some losses. And the last thing is the fiber margin for aging, because as the time passes, as you use a fiber for a long period of time, then the loss of fiber increases. So you have to put some margin. Generally, if you have a margin of 3-4 dBs, then that fiber can work for you, for example, for 10 to 20 years. So this is a budget. As we said that minus 10 we are sending, and minus 33 we can receive. So it means we have a available power of 23 dB. So as this we saw, this was a length of 40 kilometers, which is a very typical length within a city, and even for a big city, 40 kilometers is a very typical length. And if you have a normal fiber of 0.25 dB per kilometer, it means that your transmission loss is basically only 10 dB. But because you have some connectors as well, you will connect these fibers at some places, and we assume that you are using 6 connectors somehow, then it means you may be using 4.5 dB for connector, because connector has a higher loss. And if you have splices, like I told you that this 40 kilometer cannot be a single fiber. For example, there are 8 kilometer fiber reels, so we make 4 splices in between. So it means that we are using 0.1 dB for one splice, and this is not a, this is very good typical number, but this may go high also. If your technician is not good, then he can give you more loss than 0.1 dB. So basically a link will give you almost 15 dB loss. So we can say that on this link we have a margin of 8 dB, but some of the margin we put as a future margin. Like for example, we can assume that there may be some repairs in the future. So we can put some margin for the future and some margin for the life or the aging of the fiber. So if we put 3.5 dB as the future margin, still we have an excess power of 4.6 dB. So which is a good number. I mean, if we are above this minus 33, even for 1 or 2 dB is as well, then our link should work fine. Because for a normal link, we have to just check the power budget. If the power budget is within the limits, then the link should work fine. So I hope you should like this video. Just for a small introduction, my name is Aziz Khan, and I am a telecom engineer working in the field of transmission for last 20 years, and I have worked a lot on optical fiber networks. So I just wanted to share some of my experience with everyone. So if you like this, or if you have any comment, you can please comment on my video. And if you have any specific or any other question, you can email me, or you can connect me through LinkedIn. And also please subscribe to my channel and comment and share and like the channel and its videos. Hope to see you in some other video. Inshallah. Assalamu alaikum.